Hello everyone, I am Vijay from CSCA, bearing rule number 222118056 from BVRIT Narsapur. Today I am going to explain you about chromatic numbers. So what are chromatic numbers? Chromatic numbers are fundamental concepts in the graph theory. They are they represent the minimum colors that are required to color a graph properly. So understanding the chromatic numbers is important because it helps us to solve the problems in efficient. Solving the problem is not a matter, but how efficiently we solve the problem really matters. So by knowing the chromatic numbers, we can able to solve the problems efficiently. What are the basic concepts of chromatic numbers? So before going to chromatic numbers, first we need to know about graphs and vertices, what are the coloring of vertices and definition of chromatic numbers. Graphs and vertices. Graphs consist of vertices connected by edges forming a visual representation of relationship. Coloring of vertices. Coloring of vertices means in a graph, when we color the graph, no two adjacent vertices have same color. So that's what the coloring of graph mean. And the definition of chromatic number. So the minimum number of colors that are required to color the graph is called the chromatic number. Before going to the concept of chromatic number, first we we should be aware of graph coloring concept. So what does the graph coloring mean? Graph coloring means it is the coloring of the graph in such a way that no two adjacent vertices have the same color. The primary objective is to use the minimum colors required to achieve this proper coloring. There are some key aspects in coloring the graph. First one is proper coloring. So what does proper coloring mean? Proper coloring means we should color the graph in such a way that no two adjacent vertices have same color. Uh, the colors which are not the vertices which are not adjacent may have same color or different color, but the adjacent vertices should not have same colors. And second one is coloring constraints. The vertices which are adjacent should be distinct colors which we color. So next one is chromatic number. Chromatic number is represented by the symbol, the chi symbol. Chromatic number of a graph denoted by chi of g. It is the minimum number of colors need to properly color the vertices of the graph. Each vertices is assigned a color. No two adjacent vertices share the same color. So here we look at this example. In this example, we have violet, pink, blue, three colors. So in place of here, we can have red color also, but it is it will be not, it is not the chromatic number because chromatic number is the minimum number of colors that are required to color a graph. But here, if we use red, it will the number of colors we used are four. So it can't be a chromatic number. So here in this example, this is the bipartite graph. Here pink and blue, there are two colors. And here the vertex which is colored pink is connected to three vertices which are colored to blue. So here no two adjacent. So adjacent vertices have not same color. So this can be a proper coloring. And the chromatic number is 2. And in this example, the chromatic number is 2. Here the pink adjacent colors are blue and blue. So there are not same colors. So it is a proper coloring. And here here it is blue, and here it is also blue, because adjacent it is not there. So let us see another example. In this example, the chromatic number is 3. So here the blue color adjacent vertices are pink, blue, and violet and violet. So there are no adjacent blue colors which are associated with this vertices. And the chromatic number is always greater than or equals to 1. It never be 0. It will always be greater than or equals to 1. Let us see some more examples. So by seeing these example, you may get clarity about chromatic numbers. So example 1, complete graph. So what does the complete graph mean? In complete graph, all the vertices are connected to each other. Every vertex have a connection with all other vertices. So here this is the example for complete graph. Here the vertex which is colored orange is associated with uh, green color, blue color, violet color, red and yellow. It have connection with all the vertices, so it can be called as complete graph. So for complete graph, here K K4, complete graph K4. So what will, until now we have discussed what are what is chromatic numbers, but what are chromatic graphs? If a graph is K colorable but not K minus or colorable, those those graphs are called chromatic graphs. In those graphs, we can color the graphs by K colors but not by K minus one colors. Those graphs are called chromatic graphs. And just by seeing the graphs, types of graphs, we can say the chromatic numbers. There's no need of seeing the graphs and calculating the vertices and assigning colors. Just by knowing the types of graphs, we can directly say the chromatic number of those graphs. As is uh, in this example, we seen that complete graphs. In complete graphs, based on the number of vertices, we can say the chromatic number. If at all it is a complete graph, the number of vertices of that graph is a chromatic number. In this graph, there are 6 vertices. So the chromatic number will be 6. If a complete graph has 4 vertices, then chromatic number is 4. There is no need of assigning colors and checking the rules of graph coloring. Just by seeing the graphs, we can say the chromatic numbers. Next one, bipartite graph. If a graph is bipartite graph, there is no need of checking the graph coloring rules. Just by seeing the type of graph, it is a bipartite. If it is a bipartite graph, then its chromatic number is 2. Next, chromatic number of a star graph. So, what is a star graph? How does it look? So, this is an example for star graph. There is one vertex at middle and all are at the edge. So, for this graph, the chromatic number is 2. For any star graph, the chromatic number is 2. Just by seeing the graph, we can say the chromatic number of those graphs. If it is a star graph, then we can directly say that the chromatic number is 2. Next, chromatic number of a wheel graph. The chromatic number of a wheel graph is 3 if the number of vertices is even and 4 if the number of vertices is odd. So for the wheel graph, we can directly say the chromatic numbers. So how does the wheel graph look like? So this is how the wheel graph looks like. Wheel graph with 4 vertices. As we seen before, here it is mentioned that if the vertices are even, the chromatic number is 3. If the vertices are odd, the chromatic number is 4. So for this, the vertices are 4. There are even vertices. So the chromatic number is 3. For this, there are odd vertices. So the chromatic number is 4. So just by seeing the graphs, we can say the chromatic number. There is no need of calculating the number of colors and assigning colors and seeing the adjacent colors need not to be matched. There is no such conditions. Just by identifying the wheel graph, we can say that if the number of vertices are even, we can say that the chromatic number is 3, and if the number of vertices are odd, then the chromatic number will be 4. So there is another kind of graph, that is cycle graph. So how does the cycle graph look like? The cycle graphs are in cycle. The vertices and edges are represented in a cycle format. So these are the examples of cycle graph. So how can we determine the chromatic number of cycle graphs? Is It is easy to determine the chromatic number of a cycle graph. If the number of vertices of chromatic number is If the number of vertices of cycle graph is even, then the chromatic number is 2. If the number of vertices of cycle graph is odd, then the chromatic number is 3. So just by seeing the number of vertices, we can say that the chromatic number is whether 2 or 3. Based on the number of vertices are even or odd, we can determine the chromatic number of the cycle graph. If the number of vertices are odd, then the chromatic number is 3. If the number of vertices are even, then the chromatic number is 2 for the cycle graphs. Next, let us see the properties of chromatic number. So what will be the properties of chromatic numbers? Here are some properties of chromatic number. Bicolorable graphs. A graph with a chromatic number of 2 is said to be bicolorable. This means that vertices of graph can be colored using only two colors in such a way that no two adjacent vertices share the same color. So, if the chromatic number of any graph is 2, then we can say that the graph is bicolorable graph. We can't color those graphs with one color. The graphs min minimum colors that are required to color the graphs are 2. Then we can say that those graphs are bicolorable graphs. And another one is three colorable graphs. A graph with a chromatic number of 3 is said to be three colorable. This means that vertices of the graph can be colored using three colors in such a way that no two adjacent vertices share the same color. So, just like the bicolorable graphs, here also, if the number of if the chromatic number is 3, then it is three colorable. We can't color those graphs with two and one colors. In minimum, it is required three colors. So just if if we color the graph only using the three colors, and that is the minimum number of colors, then those graphs are called three colorable graphs. Next one, complete graph. As we see in above, the complete graphs, for the complete graph, the chromatic number is equals to the number of vertices that are present in the graph. And cycle graphs. The chromatic number of a cycle graph is 2 if the number of vertices in the graph is even, and it is 3 if the number of vertices in the graph is odd. Based on the number of vertices, we can easily say the chromatic number of those graphs. No need of the calculation of assigning colors. So just by seeing those vertices, we can say the and we can determine the chromatic number of those colors. So these are the examples for graphs which we can easily determine. I hope you understand the concept of chromatic numbers and what is the importance of chromatic number and how we can determine the chromatic number. And based on the types of the chromatic number, we can easily we, based on the types of graphs, we can easily determine the chromatic number. So just so first we have to identify which is the graph belongs to which type. So if we know the type of the graph, we can easily determine the chromatic numbers. So that is my presentation. Thank you. Yeah.